Okay, welcome back, everyone. I've got some exciting things to share. I'm going to share start to make videos that are kind of a little bit shorter, and I'm going to go over specific concepts, and then I'm going to eventually take you back to that hieroglyph in Egypt and take it apart, and then show you some other very fascinating connections. So if you journey with me along this way, I'm excited to share what I'm seeing in the math. So let me pull up my screen here and pull up the PowerPoint presentation. Get that pulled up here. All right, so there it is. And hopefully everybody can see that. I'm putting this up here. Okay, so there it is. And we've got the PowerPoint on the very first slide. All right, so let's talk a little bit about the larger picture, and I think it's very actually quite important. So we want to talk about how physical matter comes into existence. And if you look at so we're talking about things that are invisible. So if you were to look between me and you, the one common thing that you would see is that there's space. And in that invisible space, the physicists know it's chock full of energy. And out of this invisible, it gives rise to the visible. So we want to try to understand where the physical comes from. And this is something that really fascinates me. And the Egyptians in ancient Egypt, eternal Egypt, they were fascinated by this, and I believe they had the answers to this. So you have the civilization hit very high levels from an architectural standpoint, level of consciousness. So let's talk a little bit about that. So if you talk about standing waves or oscillations, vibrations, it's standing waves that will give rise to form, shape, geometry. And it's this that I want to talk about. So when you look here, I will be talking about standing waves and what exactly are standing waves. So standing waves have magnitude. This is the traditional definition in physics, but they don't have direction. So you drop a pebble into water, we're talking about standing waves. There's a standing portion, and then there's a portion which we will consider to be, I could call the antinode portion of the wave. And then there's a portion of the wave that is the node portion, the rest portion. And those two together will create the standing waves. So we want to look at kind of what are these standing waves? Where do they come from? What geometry do they produce? And in my mathematical system, and just like if you look at cultures, ancient cultures, the circle is very, very important. And currently in the Euclidean geometry, the circle is defined by 360 degrees. And this is what, if you look in our mathematics, that everything is referenced to this 360-degree circle. Now, I in my mathematics have modified that. I've actually added 3 degrees to that. And from 360 degrees plus 3 degrees, I'm talking about a scalar circle. And you're going to see in my mathematics how we have a whole number, rational number that has more of a harmonic geometry associated with it. And I'm going to be talking about whole numbers and how proportions, ratios can actually show up in this mathematical system. So I will refer to the scalar system or scalar circle as being 363 degrees. And we can talk about how we can place the standing waves, how they'll fit into the scalar circle. But imagine that you could take it and fold it in a way that it would, within the scalar circle, you would have 7 gates. So within the scalar circle, if you were to divide that into 7 intervals, you'd get these 7 points that are shown up here, which actually maps out in geometry what's called a heptagon. A heptagon is a polygon. It's not talked a lot about, but the number seven is talked a lot about. And mathematicians know that the number seven has very interesting properties. So I really want to go over this concept of building stable geometry from oscillation standing waves. Here are our seven gates, and I'm going to refer to these two as the Osiris gates or the Osiris keys. And I'll make this connection because personally, I'm seeing a connection between that language and the mathematics. And we're going to be traveling along looking at this, and it'll be interesting to see how these are correlated with one another. So we'll talk about dividing up this 363-degree scalar circle by the number seven. And you can see here how we're doing that. Now, in my mathematics, I have talked about geometry, how the geometry, specifically the square base pyramid, is phase shifted by 9 degrees over the Euclidean square base pyramid. Now, what these numbers represent, if you do the calculations, a standard Euclidean square base pyramid, like the one sitting in Egypt, in Cairo, it has a total of 6 triangles. There's a square base, which is if you put a diagonal through it, you'll get 2 triangles. And then you have 4 triangles that are the faces, 6 triangles together. Each triangle in Euclidean geometry is 180 degrees times 6, which is 1080. The summation of the internal angles reflects the magnitude, amount of energy that the container can hold. And this is why it becomes important that we track these angles. And in mine, it is shifted. It's shifted by 9 degrees, which takes it from 1080 to 1089, which I'm going to refer to as the joule. And this joule here is the basic or fundamental frequency. And if you take 6 times 181.5 degrees, you end up getting 1089. So this is the same concept. 2 triangles that are at the base, 4 at the faces. 33 times 33 is 1089. So this is actually built from, 1089 is actually built from mathematically if you take 3 times 11, which is 33, and then you raise it to the second power. So these are 2 primes, and I'll be talking about these primes and these numbers and how important they are. So if you look at 1089, you'll notice something interesting about it. You'll notice that its mirror is 1089 times 9, which is 9801. So this is, you can see, is written backwards. So the numbers in the system do some very spectacular things. Mirrors in nature are incredibly important, and everything's mirrored. So I'll talk about reflection. I'll talk about mirrors. Little later, I'll talk about what's called iterated subtraction, and I'll tell you how that all fits in. And then there's some interesting things about the numbers that mathematicians know about that you can take. There's a little classical trick. You can take any 3-digit number, reverse and subtract it, and then add the reverse, and you will always land at 1089. So 1089 is doing something very, very special, very, very unique. And then if you haven't noticed, 3 times 363 is 1089. So if you look at it, the scalar circle is 363. If you go around 3 times, you will get 1089. You add the digits, they add to 18, or they have a digital root of 9 if we take this to a single number. So we'll be talking about 1089, and I want to show you something before we go a little bit deeper. Why is this so important? So I placed the geometry over here that's the Euclidean on the left. 1089 times k is here. This is the second column. 1080 times k is the first column. First column, Euclidean geometry. Second column, the phase shifted geometry, the scalar geometry. And we started with 1080, 1089. I told you this was the jewel. 1089 was the jewel. This is the square base pyramid. Then we can go in multiples of this, 2160 in Euclidean, 2178 times 3, 1080 times 3, 2240. So if you go down there through here, you'll see some very important geometry that will pop up in Euclidean geometry. For example, 2160, this is equivalent to the cube. Or in my mathematics, I have 2178. Then if you go further down, the 5400 and 6480, these are important structures as well. 6480, this is the pentagonal dodecahedron. And over here, 6534. Now, one thing you'll notice, the differences between the actual Euclidean geometry and the scalar geometry. Notice if you take 1089 minus 1080, 9, 2178 minus 2160, 18, you're actually going to see the 9 times table, the difference between these two. This is very fascinating. And you see within your own 9 times table, when you hit 54, it's a reversal of 45, 63, 36, 72, 27. So in itself, you're seeing a reversal or a mirror. We can talk more about that, but I just wanted to introduce that. Now let's go back to the scalar circle at 363 degrees. So you can see the heptagon on the inside. Now, in the ancient Egyptian times, everything was proportions and ratios. This is consistent with whole number geometry. And I want to look at 1/7. I'm going to take the number 7 and I'm just going to put 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, 7/7. I'm going to place these fractions or these proportions that we're looking at onto the heptagon. And if you take your calculator, and this is what the mathematicians know, that you will get a 6-digit repeat for 1/7. And you can see it 0.142857. And this number will reappear, the same 6 digits. If you put your calculator, turn it on the side, take a look at this. It's a 6-digit repeat. This is very, very fascinating. And this 6-digit repeat, I will later show you, will form 2 triangles, which will later give rise to a tetrahedron. That will be something that Buckminster Fuller demonstrates, and I will show you this. But for now, we're just going to look at these 6-digit repeats. There's no 3, there's no 6, there's no 9, but it adds to 27 if you add these 6 digits. Now, 2/7, here is the 6-digit repeat. 3/7, here's the 6-digit repeat. 4/7, 6-digit repeat. 5, there's all permutations of the 6-digit repeat. No 3, no 6, no 9. Tesla was about 3, 6, and 9. They're not showing up here, but they're on the grid, the 3, 6, 9. Talk about that a little bit later. The other interesting thing, as you see, as these are permutations, I'm placing them here. So the 1/7, I'm putting these onto these nodes. Now this is interesting. So I placed in here the divisions, where we have 1/7, 2/7, 3/7. But let's go further as we treat this like a clock as we're going clockwise. I want to look deeper. There's a lot here. Notice that these node 6 and node 1, we could add these 2 up. 6/7 plus 1/7, 7/7. This number here will be 0.9999999, but this is going to be 1. Same over here. 5/7, 2/7. We can add those up. 4/7, 3/7. So this in itself is a mirror, except this node that's sitting up at the top, which is the 7/7, which I'll refer to as 1, or sometimes we could consider this as 0. So let's now talk about converting 363 into degrees. So if we divide by 7, we'll get 1. We'll take 363 times 1/7. You'll get 51 degrees in this change over here that's in the decimal points. If we take 363 times 2/7, you'll get this. Or we can simply go around in 51.857142 increments as we go around the scalar circle from node to node. This is reflecting the arc from node to node. And you can see ultimately we end up at 363. Now in this, I want you to we know that the very first node should correspond to 1/7. Look at the matching of here. So we're going to skip the first 3 digits because this has to do with the permutations and the mirror. And you're going to see how we can place accurately with the repeats of dividing by 7, 142,857, right back onto the 1/7 of where 1/7 falls on the scalar circle. Look at all of these. All right, so what I'm doing is I'm literally placing the degrees of the circle, and I'm connecting it to the 6-digit repeat pattern. Okay, so you can see as we go through here, I've done that. Now, the other thing, so if we go back, let me go back here, you can see these nodes and the corresponding decimals that are here. Okay, and these are, if we place the degrees as well of the scalar circle on there, you'll get the same thing. So then what I did was I divided the 1089 multiple family. I was curious to see where they would fall on the heptagon, and they are direct hits. For example, 1089 divided by 7 will give you 155.571. Again, skipping these first three digits past the decimal point, picking up the 6-digit repeat pattern here. These are the signatures that I'm placing over here. 2178 divided by 7, you'll get this number. Skip the first 3 digits past the decimal point, you get this signature. So you can actually then begin to place those back onto the scalar circle and see where they land here. 1089 will land at the third node right here, because look, 428571, that's this node. 2178 will land at node 6, okay, lands on 6/7, will land over here. We can reconstruct where the 1089 family will fall. They fall perfectly on these nodes, which is fascinating in itself. And then watch what happens when we step from node to node, from 1089 to 2178 to 3267. Look what happens. So we're going to start here. This is 1089, the third node. We'll go over here to the 6/7. This is 2178. This is node 6. We then can go to the 3267, which is going to be node 2. And you're literally going to see, we're going to trace out a 7-pointed star, a heptagon. A heptagon internally, but this is the 7-pointed star, is known as a heptagram. Now, this is describing the flow of energy. And we've got geometry here, and I want to show you something as we go a little bit further. I'm going to go through these slides. I'm going to take you right here. Goddess. And this goddess here, Seshat, has a 7-pointed star as a crown here, just like the Statue of Liberty. Yes, look, there's a 5-pointed, pentagon, or a pentagram, people would say, pentagram on the inside of this 7-point star. What does that mean? There's 7 plus 5 is 12. A lot of people are hunting for the importance of the number 12. I think I know it. It's energetic. Stay tuned. I will share that with you. So let's review what we saw. I showed you a scalar circle. I placed a heptagon on the inside of the scalar circle. I showed you exactly how the 1089 multiple family will fall onto these nodes of this scalar circle. And so we've got the scalar circle as the carrier. We've got the wave folding back, and we're forming these these nodes, and you're seeing how the energy can move. We're matching this up to an ancient glyph that sits in Luxor in Egypt as a message, something left behind. I don't believe the gods and the goddesses are going to place this mathematics where it's so clear for us to see. We are going to have to unravel what they left behind in their glyphs. It's not going to be just where you read one thing, the math, the geometry, the measurements are all there. They're all there for us. And it's time we read them. All right. Share this video. Share it. Have people subscribe. It's going to be an amazing ride. I've got amazing things to tell you. So stay tuned and share.